It's very easy to understand the laws of indices if you understand one thing, and that is, if we write it a to the power m, it means it's a multiplied by a multiplied by a m times. So if it is 3 to the power 3, it means it is 3 times 3 times 3, which is 27. So from this we can easily get the first law of indices. So a to the power m times a to the power n is equal to what? So obviously if a to the power m is going to be a times a m times, and a to the power n is going to be a times something n times, right? So we have a total of m a's here and n a's here. So in total we have m plus n a's. So this is equal to a to the power m plus n. Similarly, a to the power m by a to the power n. So this is the first law, this is the second law. This is equal to a to the power m minus n. And how is that? On the top we have a times a, and this is multiplied m times, right, upon a times a, and that is n times, right? So let's say if this was 3 to the power 4 times 3 to the power 2, this would be 3 times 3 times 3 times 3 divided by 3 times 3. And so you have 4 3's at the top, you have 2 3's at the bottom. So if you cancel this out, right, you have 4 minus 2 3's, right? So this is equal to 9. And then we have a to the power m to the power n, and this is equal to a to the power m times n. So how does this work? So let's say this is basically a to the power m multiplied by a to the power m multiplied by a to the power m n times, right? And each of these has got a times a, and this is m times, right? And then this is n times multiplied together. So let's say we had 3 to the power 4. This would be equal to, let me correct this, let me write this a bit more clearly. Okay, so let's say 3 to the power 3 maybe times 4 to the power 4. So this would be 3 to the power 3 times 3 to the power 3 times 3 to the power 3 times 3 to the power 3. And each of these has 3 3's, right? So by the basic definition, 3 to the power 3 is 3 multiplied 3 times, and then this as well, similarly the other two. And if you count all of these, this is 12. So it's basically 3 3's in each bracket and then 4 brackets. So it is 3 times 4. So in general, a to the power m times n is equal to a to the power m, a to the power m to the power n is equal to a to the power m times n. So that's the third law. The next one is a to the power m, a to the power minus m. This is equal to 1 by a to the power m. And how do we understand this? So let's say a to the power m is equal to something, right? Equal to what? So let's say this is equal to x. Okay, we don't know what x is, Going back to this law, the very first law, so a to the power m into a to the power n is equal to a to the power m plus n. What we are going to do is we are going to multiply this both sides by a to the power m. So a to the power minus m into a to the power m is equal to x into a to the power m. Now if a is not 0, a to the power m will not be 0, and we just need to assume that for now. I'll actually prove that in a later video. So okay, going by the first law, a to the power minus m into a to the power plus m. So this is equal to a to the power m minus m, which is equal to x times a to the power m, and this is basically a to the power 0 is equal to x times a to the power m, and to continue this, so a to the power 0 is equal to x times a to the power m, right? And now if I divide both sides by a to the power m again, we have a to the power 0 upon a to the power m is equal to x. And let's actually go to the fifth law as well, which is a to the power 0 is equal to 1. So any number to the power 0 is equal to 1, and we will prove this in just a second. So if a to the power 0 is 1, this means that x is equal to 1 upon a to the power m. But what was x? When we assumed x, it was actually a to the power minus m, right? So a to the power minus m is equal to 1 upon a to the power m. So basically this is the proof, but you can remember it as a way of writing. So basically if something is negative, it is below 1 with a positive number, and that is how I remembered it for a long time before understanding that. Now a to the power 0 is equal to 1. So say a to the power 0 is equal to 1 is our next law. And how do we prove this? Let's say a to the power 0 is equal to x. Again, we don't know what x is, right? So we have to prove that x is equal to 1. Let us multiply both by a. So a to the power 0 times a is equal to x times a. Now what is a? A is basically, we assume a is non-zero first of all, but a is also a to the power 1, right? So let's say a to the power 2 would be a times a, but a to the power 1 would be a. So what we do is we change this a with a to the power 1. So a to the power 0 times a to the power 1 is equal to x times a. Now going back to the first law, what was the first law? A to the power m plus n, sorry, a to the power m into a to the power n is equal to a to the power m plus n. That was the first law. So a to the power 0 times a to the power 1, this is going to be equal to a to the power 0 plus 1. This is equal to x times a, and then that means that a is equal to x times a, and a is not 0, so x should be equal to 1. So that's why a to the power 0 is equal to 1. And the final law is basically a root. So it says that a to the power m by n is basically the nth root of a to the power m. So obviously if let's say for a simple example, if we had 2 to the power 2, this would be equal to 4, and then if we have 2 to the power 2 divided by 2, right? This is equal to the second root or the square root of 4, which is equal to 2. This is also equal to 2 to the power 1, right? So 2 and 2 can basically cancel out. But in general, let's say we had a to the power 1 by 3. This would be the cube root of a. So coming back to the general form, how do we actually understand this form? We know that a to the power m is basically a multiplied by a m times, and we don't really need to care about that for now. We just need to care about the 1 by n part of it. And how to prove that? So let's say a to the power m by n is equal to something x, right? So let's say I raise this to the nth power. So let's say a to the power m by n times to the power of n is, this will be equal to x to the power of n. So both are raised to the power n, right? So a to the power m by n times n, and this is basically, this was the second law that we learned, and that is right over here, right? So this is equal to x to the power n, right? But then this is equal to a to the power m by n times n, and this cancels out. So this is equal to a to the power m, which is equal to x to the power n. So again, if you take the nth root, x should be equal to the nth root of a to the power m. And what was x? X was equal to a to the power m by n. And that is the final law.